Lesson 9.4, Solving Quadratic Equations by Completing the Square. Our essential question is, how do you solve an equation by completing the square? And our vocab word is also completing the square. What completing the square means is turning a quadratic into a perfect square. And in order to do that, you need to remember what a perfect square looks like. So a perfect square could be something like x plus 5 squared. And remember, that means x plus 5 times another x plus 5. So if I FOIL that, I'm going to get x squared plus 5x plus another 5x plus 25, which simplifies to give me x squared plus 10x plus 25. So the key to completing the square is going to be recognizing the relationship between these two terms. These two terms. So remember, we said that this term right here, 25, that's the same as 5 squared. But 10x is 2 times 5 times x. So it's 2 5x's added together. So the relationship, if we're trying to figure out the value that would complete the square, the relationship that we're going to have to use is that c equals b divided by 2 squared. C equals b divided by 2 squared. If I try that out on this example that I just wrote, so the example that I just gave you, I have a value of a that is 1, b is 10, and c is 25. So we're going to check and see if this works. C equals b, which is 10, divided by 2, and then you square it. 10 divided by 2 is 5. 5 squared is 25. So that's exactly what we're going to do. So the relationship that you have to remember is right here. C, the value of c, is equal to whatever b is divided by 2, then squared. That will complete the square for our trinomial. Okay, so first we're going to practice just finding that value of c that makes the quadratic a perfect square. So c equals b divided by 2 squared. So my first one would be negative 12 divided by 2 squared. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So my answer is 36. That's the value that would complete the square. The next one, c equals b divided by 2 squared. On this one, b is 4. So 4 divided by 2 is 2. 2 squared is 4. So 4 would complete the square. We have 2 more, and these two have odd numbers. So I just want to make sure that you understand what happens when you have an odd number for b. So if I plug in negative 3, I have negative 3 over 2, and I square it. What I actually want to do is I want to leave it a fraction and just square each number. So it would be 9/4. Negative 3 squared is 9, and 2 squared is 4. And then the last one, I plug in 7, 7 divided by 2, and then square it. So I would get 49/4. So this first set of examples is showing us how we can complete the square on a trinomial. So figuring out the value for c that would turn a trinomial into a perfect square. Now on this next slide, we're going to start using that idea. So these are going to be very different for you. So please take careful notes. So the first thing we're going to do is we are going to subtract 5 on both sides. Because 5 is not a perfect square trinomial. The left-hand side here is not a perfect square trinomial. So I can tell that right away. So I'm going to subtract that 5 like this. And then I'm going to write in my plus c. And we are going to complete the square on the left-hand side. And after we do that, completing the square, then I'll show you how we can solve the remaining equation, okay? And we're going to use the property of square roots when we do some solving here. So what would make a perfect square trinomial on the left-hand side? C equals 6 divided by 2, and then I would square it. 6 divided by 2 is 3, 3 squared is 9. Now, here's the deal. If I want to add 9 where the c is on the left-hand side, I am also going to have to add 9 on the right-hand side because we know that that's a rule for solving equations. You can't just add something on one side without adding the same thing on the other side. If you do add something on one side and not the other, you're changing the equation. So it's not going to be an equation at all anymore. You're making it an inequality, not an equality. So anyway, now on the left-hand side, I know that this is a perfect square. It's x plus 3 squared. On the right-hand side, 7 plus 9 is 16. And that's really good news for us because now this is an equation like what we solved when we did chapter 10 and we worked with square roots. So we can solve this equation by taking the square root of both sides. Now remember, there are technically 2 square roots of 16. One of them is 4, and the other one is -4. So don't forget to use both, because we're going to solve both of these equations. I can subtract 3 on both sides of both of them. And my first solution is 1. My second solution is -7. So I have 2 solutions, 1 and -7, that would work in this quadratic. So those are my 2 answers. So again, think about the process. First, we had to move this value of c. We had to get rid of it because it was not a perfect square trinomial. It was not a perfect square. If you don't believe me, look at the work right here to show it. If we take 6, take our 6, divided by 2, we get 3, square that, we get 9. So 9 is what we needed to have a perfect square, not 5. So we subtract away the 5 to the right-hand side, then we add the 9 to both sides, because now we've created a perfect square. And then we can use the property of square roots to solve the quadratic. Our next example, I'm going to start out with this -6 and just show you why the 12 isn't going to work for us. So I'm going to square it. So -6 divided by 2 is -3. -3 squared is 9. So I need c to be 9. So that means I'm going to get rid of this plus 12. So subtract it on both sides. X squared minus 6x. And 19 minus 12 is 7. Oops. Okay, so I know that I need my c to be a 9. So x squared minus 6x, I need to add 9. So then on the other side, I'm also going to add 9. Perfect square, this time it's x minus 3 squared, but it equals 16 again. So good news. Square root of 16 we know is 4 or negative 4. So x minus 3 equals 4. X minus 3 equals negative 4. If I add 3, I get 7. And adding 3 over here, I get negative 1. So positive 7 or negative 1 are the two solutions. Third example, I'm going to check this negative 18. So negative 18 divided by 2 and then square it. So that would be negative 9 squared. So C has to equal 81. It's definitely not 81 right now. So subtract 5 on both sides. X squared minus 18x. And it equals negative 17. Now we know that we need our C to be 81. So x squared minus 18x plus 81 equals negative 17 plus 81. My perfect square on this one would be x minus 9 squared. And then 81 minus 17 is 64. Good news, that's a perfect square. So x minus 9 equals 8, or x minus 9 equals negative 8. And then solve both of those. Add 9 on both sides. X equals 17. And x equals 1. Now, this is our last example. So I want to make a point of telling you that this number over here does not have to be a perfect square. And if it's not a perfect square, that's okay. So for example, if that was the square root of, just going to make up something that's not a perfect square, if that was the square root of 68 instead of 64, we would have split it and we would have just used 8.2 and negative 8.2. When we set it equal to 8 right here, it just would have been a decimal value. And that's fine. That's completely fine. Because you can take the square root of any number. It doesn't have to be a perfect square. Perfect squares just make your answers a little bit easier to work with. But on your homework, you might see some that are not perfect squares. So don't worry about it and think that you can't solve it. You can still solve it. Just use a calculator and round that square root to the nearest tenth. So you should be able to write a summary now about how you solve a quadratic using this new method, completing the square. And here are your homework problems.